solving trig identities with Righty the Triangle.
I heard you were having some trouble with solving your trig identities, but solving trig identities is really pretty simple. Here, I'll show you how. Let's get to it. We're going to start by writing out the equation. Remember, it's not an identity until we prove that both sides are equal. Now, draw a line in between both sides, because when solving a trig identity, you cannot multiply, divide, add, or subtract by a like term on both sides. This line will remind us we cannot do that. Let's rewrite the fraction on the left to be in two parts. We know that the definition of tan theta equals sine theta over cosine theta, and we can use rules of exponents to find out that tan squared theta equals sine squared theta over cosine squared theta. Now we're going to apply this information to the left side of the equation, and rewrite tan squared theta over 1 to be sine squared theta over cosine squared theta. And we also know that the definition of secant theta is 1 over cosine theta. And therefore we can write 1 over secant theta to be 1 over cosine theta, which can just be rewritten to be cosine theta over 1. And now we can cross multiply, and then we'll get sine squared theta over cosine theta. And now on the right side, we can rewrite tan theta to be sine theta over cosine theta. And if we multiply those two right side terms together, we'll get sine squared theta over cosine theta. Sounds familiar? Now the left and right side match, which means that you just solved this trig identity. Good job! I hope you had fun with trig today. Bye, everybody!